Kyle with Thompson Linear here. I'm going to walk you through the installation screens on the Thompson UR cap and how to set up the collision detection settings. On first installation, what we need to do is go ahead and home the 7th axis. A homing process the unit will move to the home switch on one side, then move to the limit switch on the other side. That'll set a 0 position and also the available stroke. Well, first, before that move is made, our cap allows to set a homing pose. We can set a safe homing pose for the robot to move. Once that's established, we can go ahead and hit our Run Initial Homing Move button. And we'll see the 7th axis move to the home switch, establish that 0 position, and then very slowly it's going to move to the other side, limit switch, to establish the available stroke. So the 7th axis has reached the switch. It's established the available stroke. It's able to move. Also set software limits as a belt and suspenders kind of backup. And once that's done, you'll see the indicator light has turned green that the 7th axis has been homed. So now that we've homed the Thompson 7th axis, we can move over to the parameters and sensitivity tab. And when you go on this tab, you'll see on the right-hand side, there are 3 options for the 7th axis motor tuning. You can see in the manual the different recommendations depending on if the application requires really smooth motion or kind of the highest accelerations possible. If you're unsure, we do recommend the average tuning. Once you've selected the tuning, you can see there's a slide bar for velocity and acceleration. Those can be set, and then we're going to go ahead and run a test move, which will establish a max current on the motor. We do recommend on this default move parameters that you use your most aggressive velocity and acceleration move, which later can be customized for each individual linear move later on in your programming. So let's go ahead and run that once we've selected our velocity and acceleration. Let's go ahead and hit our apply settings and run a test move. And what this will do is at those default move parameters that you've set, go ahead and move to the home switch and then do a full stroke to the support side limit switch. And that move has established a maximum current in the motor drive. Once the velocity and acceleration parameters have been set, a test move has been run to set a maximum current limit in the motor drive, we can go ahead and set the collision sensitivity adjustment. So this is a slider bar very similar to the joints in the robot that can be adjusted from least sensitive to most sensitive. So we can apply the settings here, and then we do need to validate how that feels. And to do that, we'll go ahead and run a calibration move. We'll have the 7th axis move, and then intentionally create a fault to get feedback on how that sensitivity level feels. So we're going to have the actuator move towards me. I'll go ahead and intentionally create a fault, and that felt pretty good. So I'll see a safeguard stop pop up on the tablet. We can go ahead and clear that safety stop in the Thompson toolbar. And then if needed, we can go back and adjust the sensitivity level. One thing to point out, depending on the velocity and acceleration, if you adjust the collision sensitivity really low, you could get a scenario where you see something like this when we run a calibration move. So the 7th axis tried to run, and actually the weight of the robot and the speed itself was enough to trip that calibration. So what we need to do is go into our toolbar, let's clear that stop, let's go back to that slider bar and sensitivity and then just adjust that back up. We can apply those settings, run another move, and validate we like the settings there for the collision sensitivity. So I just want to highlight some of the functionality available in the Thompson toolbar. So if you go into the toolbar in the top right hand of the UR tablet, you see one from the collision sensitivity. That's where we can clear any kind of safeguard stops. But you also see a jog plus and minus. So if you hold those buttons down, that will move the 7th axis at the default move parameters in those directions. The other thing that you'll see in the toolbar is a free drive button, and we can turn that free drive on. And this is very similar to the free drive button in the joints, but now where we contact these paddles, we can move the 7th axis to a position to be able to program. So we can move it in either direction. We can do big pushes for higher speed and small taps for small movements. One thing to note, the limit switches are active always. So if we've shoved this down to the end, it's going to run into the limit switch. It won't let us go past it. And then when we're done moving the 7th axis around, go ahead and hit the free drive back off.